Two dice are rolled, determine the probability that the sum of the dice is 3 or 11.
2 or 1?
You have two dice rolled, and I want the sum to be 3 or 11. What will make the sum 3? Give me examples. 2 and 1. 1 and 2 also, because it could be 1 on the first die and second is 2. It could be the opposite. It could be 2 on the first and 1 on the second.
6 and 5?
Yeah, the 11 will come from 6 and 5 or 5 and 6. So how many total outcomes? 7. Can you have 7 in die? No, the die ends at 6, right? From 1 to 6. So there is no 7 and 4. So that's it. Am I missing anything? No. So there are 4 outcomes. 4 out of how many total? When you toss 2 coins. Do you remember the fundamental counting rule? Fundamental counting rule, if you have something happened with a number of possibilities, and then again another one happened with a number of possibilities. The first one 6, the second one 6. So what do we do?
36.
36. We multiply it. That was the fundamental counting rule. When we multiply the number of options in every stage to get the total number of outcomes. Remember?
Yeah.
Remember I told you how many I can dress if I have 2 trousers, 3 belts, and 4 of this, so that would be 2 times 3 times 4. That's it. So the total is 6. So the answer will be 4 over 66.
But how can you calculate the same thing without manually listing?
Yeah, in the case of 2 dice, you can do 2-dimensional table like this with all the outcomes. So you have 1, 2, 3, 4, 5, 6. And the second die will be also 1 or 2 or 3 or 4 or 5 or 6. This will take a bit more time, but it will make you more confident about the answer. So in this case, imagine you're getting the summation table. So 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, and then 5, 6, 7. Similarly, for the second row will be 3, 4, 5, 6, 7, 8. And then 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. And finally, 7, 8, 9, 10, 11, 12. So remember, all of these are the sum. So you're looking for a sum of 3. So that's a sum of 3. That's a sum of 3. You're looking for the sum 11. That's a sum 11. That's sum 11. That's it. So you have 4 outcomes. And the total is 66.
This is still manual. That's simple.
What do you mean?
What I mean is like
A rule?
a rule.
No. There is no rule here. No, there is no rule. No.
Can number can be twice, like if we have like 6 and 8. Can we write like 3 and 3 and 3 and 3 again?
What do you mean 6 and 8?
Like
If the question says 3, 6, and 8, okay, so we forget about this question.
Yes.
Make it 6.
6 and 8.
Let's just do that in a different color. Okay, suppose that 6 or 8. Okay, remember the 6 come from where? 3 and 3.
Can we say that again?
Why do you say 3 and 3 again? If you look at the 6, actually they are here. This one and this one, and this one and this one and this one, right? See, that one is 3 and 3. It's only one time happens. The 2 and 4 is happening twice because you have 2 and 4 and you have 4 and 2. So that's why you have 2 of them. That's different. But the 3 and 3, the same thing. Why do you duplicate the same thing? So that's why this table sometimes give, clear interpretation of how you can find, these outcomes. Does it make sense? So in this case, I have these are the 6. Suppose I'm looking for the 8 also. So this is 8, 8, 8, 8, 8. So how many of these now? 1, 2, 3, 4, 5. 1, 2, 3. That's a total of 10 over 36. So the probability here, the probability of getting a sum of 6 or 8 is equal to 10 over 36, which means 5 over 18. In this case, of course. Okay? Clear that? Any questions? Did I make any mistake anywhere? Don't think so. So that's also some of the famous examples about, when you roll 2 dice, what could be the outcomes.